In this video, we're going to be talking about intercept form. So intercept form is y equals a times x minus p times x minus q. And we'll get even more practice with this form in our next unit. So just like in our other forms, each part of this equation tells us a certain characteristic of our parabola. First, if a is greater than 0, then the graph opens up. So it makes a U shape. If a is less than 0, then the graph opens down. And it looks like this. So just to note, this is the same a in vertex form and standard. So it tells us the same thing as it does in those other forms. And then something that's unique to this form is that it actually tells us what our x-intercepts are. So here our x-intercepts are p0 and q0. And so just like from vertex form, it's really going to be the opposite sign as you see in here. So for instance, let's say I had y equals x minus 1 and x plus 4. That would mean my x-intercepts would be 1, 0 and negative 4, 0. So I take the opposite sign of what I see in those parentheses. And then from this format, you can also find the axis of symmetry and vertex. So your axis of symmetry would be p plus q divided by 2, and then you can plug that in to find your vertex. So let's do some practice with writing a quadratic equation from a graph, but this time we are given the two x-intercepts and a different point. So looking at this graph, I see that I have my two x-intercepts. Remember, your x-intercepts are where your parabola crosses the x-axis. So I see I have an x-intercept at negative 3, 0 and one at 1, 0. So that means that my p is going to be negative 3 and my q is going to be 1. You could also flip-flop that. My q could be negative 3 and my p be 1. You'll still get the answer at the same answer at the end. And then I'm given just another point. So my x is negative 2 and y is negative 9. So I'm going to plug that into my intercept form. So my intercept form is y equals a times x minus p times x minus q. Well, my y is equal to negative 9, so I have negative 9 is equal to a, which we're trying to find, times x, which is negative 2, minus p, which is negative 3, times x, which is negative 2, minus q, which is 1. Well, negative 2 minus negative 3 is the same thing as saying negative 2 plus 3, which is 1. And then negative 2 minus 1, I get negative 3. So I have negative 3a. Divide both sides by negative 3, and I get that a is equal to 3. So plugging that back into my intercept form, I have that y is equal to a, which is 3, times x minus p, which is negative 3, times x minus q, which is 1. So I have y equals 3 times x plus 3 times x minus 1. Okay, let's look at another one. Here I have this graph, and so I see that I have actually 3 intercepts here, but I need to make sure that I remember which one are my x-intercepts. My x-intercepts are those that cross the x-axis. That's going to be this 1, 0 and 3, 0. So I'm going to label 1 as p and 3 as q. And then here I'm actually given my y-intercept as well, and that's just going to be the other point. So it's going to be x and y. So I'm going to plug that into my intercept form so that we can find what a is equal to. So here I have y, which is -2, is equal to a times x, which is 0, minus p, which is 1, times x, which is 0, minus q, which is 3. 0 minus 1 is -1. 0 minus 3 is -3. And so I have -2 is equal to -1 times -3, which is positive 3a. And then divide both sides by 3. And so I get that -2/3 is equal to a. And so plugging that into my intercept form, I get that y is equal to a, which is -2/3, times x minus p, which is 1, times x minus q, which is 3.